These faces are ambigrams, images that are legible both upside down and right side up. Created with a machine learning system, they may be displayed and viewed in any orientation. In this project, we generated a collection of 55 such ambigrammatic faces and present them in a variety of different formats. Some of the best-known ambigrams are a series of reversible faces by the British artist Rex Whistler, created in 1931, and a collection of playful upside-down pictures created circa 1861 by the Japanese illustrator Utagawa Yoshitora. But this illusion has older roots. In the 18th and 19th centuries, bivalent face illusions were often used to depict uncomplicated dualities such as young-old, male-female, or good-wicked. The faces in our Ambigrammatic Figures project reflect the moral ambiguities of a darker and more uncertain time, marked by ecological crisis, misinformation, identitarianism, authoritarianism, and the social unrest of a polity divided against itself. The Ambigrammatic Figures project is a variable format work. When the faces are offered as still images, we orient them sideways to preserve their ambiguity. In time-based media, we present the faces as spinning loops, or, alternatively, in bivalent videos puppeteered by facial motion capture recordings and reanimated by an image warping algorithm. The ambigrammatic figures are also presented in a tangible, open-ended, interactive format as a deck of printed poker-sized cards. Participants are encouraged to devise their own activities with these cards, such as sorting them according to subjective criteria, or giving names and epitaphs to the faces. Our initial attempt to implement the project entailed the development of a custom generative adversarial network, or GAN. In particular, our GAN's discriminator was modified so that it examined its generator's output both upside down and right side up, and produced a score that was a function of both. Unfortunately, the results of this technique failed to converge well. Ultimately, our faces were synthesized with a projection technique in which a GAN attempts to find a given face in its latent space, starting its search from a generic neutral face. We provide the StyleGAN network with an upside-down face as a query, and the projector tries its best to find it, but can never serve a perfect match because it has only been trained on exclusively right-side-up faces. In short, the GAN projector finds upside-down faces in the latent space or generatable manifold of right-side-up faces. Through the struggle to match an upside-down face using right-side-up ones, the GAN tends to converge on a face that can be looked at both ways.